Page 93, question number 3. Find the z-score for the areas shown below. Now we've got 3 different normal curves. Each one of them has a mean of 0, standard deviation of 1. And for each one, let's look at one at a time here. We're given a percentage that's shaded in. So this region shaded in is 15% of the entire curve. We want to know where z has to lie on this scale so that this region would be 15%. Same thing here. Where is z so that this region here is 42%? Where would z have to be so this region is 60%? Well, we can estimate about what our answer will be based on the tick marks on our graph. 0 is right in the center. Each tick mark is a standard deviation. So here would be -2, -1, 0, 1. So this z value is going to be about 1. Here we can see -2, -1, 0, 1. This z value is going to be about 1.3 or so. And here we have -2, -1, 0. This one's going to be about 0.2 or so. So you can get a good estimate for what your answer will be without doing any work. Okay, we can find out exactly what this answer will be by using our graphing calculator. So I'm going to go into the distribution menu, press the second key and the variables button. And the command we want in this case is the third command, inverse normal. Because we know an area under the curve, we want to know a value on this scale, in this case a z-score. Now we need to type in 3 things with this inverse normal command. The first thing we need to type in is the percentage to the left-hand side of wherever this z is. So in this particular problem, 0.15 is to the right of that z. So this percentage over here, all of this over here is 0.85. So 85% of the graph is to the left of z. That's what we put in our calculator, 0.85. Then a comma. Now we need 2 more things, but these 2 things are relatively easy because they're given to us. 0, 0, 1. And if I type that in, I get that this z value must be at about 1.0, around to about 1.04, which seems to fit on the scale. It's about what we guessed at the start. Okay, let's take a look at the next one here. So in this case, here's our z value. We're going to use the same command. We're guessing our answer is about 1.3 or so. Now we have to tell the percentage to the left of z. So this entire percentage, all of this area. We can see 0.42 is in this shaded region. What about this percentage here? Well, we know the mean is going to split that curve perfectly in half. So this is 50%. So that entire area to the left of z is going to be 0.92. That's what we need for our calculator. So I'm going to go into that distribution menu again, get that inverse normal command, type 0.92, 0, 1. And it tells me that this z value down here is about 1.41 or so, which again fits our estimate. Okay, let's look at the last one. And actually this last one's the easiest because take a look here. The percentage to the left of z is given to us. It's right here, 0.6, 60%. So I don't need to think a whole lot about that one. I can put things right in my calculator. Inverse normal 0.6, 0, 1. And it tells me that the value of z is about 0.25, just slightly to the right of 0. That seems to fit, seems to make sense.